the database manager for the MAHSA project, and I'll let him present. In the meantime, if there are any questions on Stefania's presentation or Junaid's, we'll have a very brief opportunity at the end of Junaid's presentation in order to ask those questions. But I'd just like to hand the floor straight over to Junaid to give us some case studies and an example of the data workflow in the Mapping Archaeological Heritage in South Asia project.
Thank you, Rebecca. Let me share my screen and we can start then. Can you share the? Can you see the screen now?
Yes, thank you.
Okay, perfect. Hello, everyone. Thank you to Rebecca for the introduction. So I'll be talking about the restructuring and reusing of archaeological data and how we have dealt with this in the Mapping Archaeological Heritage in South Asia project. This presentation was prepared and planned to be presented by both Azadeh and myself, but unfortunately she is unwell, so I will be doing the whole presentation. Some of the questions that we came up, that we were faced as a project, and we have also seen in the previous exercise of data management plan, were around the data collection, recording, and creation, following the FAIR principles of findability, accessibility, interoperability, and reuse. How we can share the data with other users, what kind of restrictions we can have, the long-term data preservation strategy, along with the storage and backup. In the next few slides, I'll be talking about each of the steps and how we have addressed this. So the project started with the aims to discover or rediscover, document, and disseminate the archaeological heritage in Pakistan and Northwest India. The archaeological heritage has been subject to and still in past and currently threats, including agriculture development, urban expansion, and looting, that requires the documenting of all these assets and making them accessible through a database. MAHSA and MAHSA projects are using Arch's database platform to make this data publicly accessible with registered and controlled access. So the data that will be recorded in the database, the aim is that it will be reused for future researches and analysis, and which will help the heritage managers and conservation bodies to make informed decisions for the sites. To do this, we are using a number of data sources. These data sources include historical maps. So as I have just talked about the threats to the heritage sites, these historical maps are predating the agriculture and urban expansions, and we are mainly dealing with working with the Survey of India survey map sheets, which predate the archaeological and urban expansion. And this color map sheet from 1905 and onwards have been are a great source of a number of mound features, as you can see in this image here. So these features are basically hatched mound features and lined mound features that are available in the map legends, and we are recording this as part of our project plan. The maps are getting georeferenced, and because we are dealing with a large scale of map sheets, so there is a machine learning algorithm that is getting trained on the visual representation of the mound features, and the maps are getting processed in bulk to generate output of polygons for the probable archaeological sites. We are also using the data sets from legacy data, which are previously published data sources that are in form of the books or publications available in different libraries and repositories. And along with that, we are digitizing the data using remote sensing images, for example, for using the Google Earth or using Corona or hexagon images that predate some of the agriculture and urban expansion. To do the ground truthing, we are using doing field surveys, because most of the data that is getting generated from the machine learning, we need to ground truth it and see what's the current condition of the sites on the ground and whether it's actually an archaeological site that has been recorded onto the maps or not. When dealing with the legacy data, we are using the datasets that have been that are already existing as digitized datasets. So some of the previous projects Prior to MAHSA, for example, two range projects, they also worked on the collation of legacy data from different sources. So we started working with cleaning that data set, and there were some constraints, like this data set was available only in a proprietary FileMaker Pro database. So we retrieved it from the database, and now we have moved it to our open source Postgres database where we are cleaning this. Some of the new studies are already resulting in the born digital data, where you can find a digital or a CSV file that can be readily used for analysis and to be pushed into the database with proper references and copyrights. Then we are also dealing with the non-digital data from books or survey reports. Over at the bottom, you can see a number of books that we are looking into, like Frontier Archaeology or other archaeological survey reports to digitize the data available. This data set, legacy data, can be divided into two types of data sets. One is the primary or the secondary sources. We are defining the primary source to a data where the site has been listed for the first time. And then the secondary sources are those that have been revisiting the sites and listing the sites over and over again after the initial documentation. The challenges that we are faced with is that all these sources are mentioning slightly different set of coordinates and different sets of attributes. For example, over here, you can see that Barahud is at two different locations. Similarly, this other site. So there are a number of challenges to integrate and collate these multiple data sources. We need to enhance and clean the data for any types of inconsistencies and imprecisions. To do this, we need to come up with a number of standards, like these data sets have a variation of periods. So in order to make it a clean record, we have come up with the periods to be used in the database. Here you can see the listing of those, and individual or sub periods from the legacy data that are mapped onto the main period, so that there is a lot of consistency between different sources. Different sources are also recording the geometries in, some are recording in degree minutes, some are recording in decimal degrees. So for ArcGIS compatible data, we need the data to be available in the well-known text format, which is a format mentioned over here. It requires a prefix of point and then brackets and latitude and longitude values. And we are also using the SciDoc CRM, which is basically used in ArcGIS database to keep the things interoperable and standardized. It is a theoretical and practical tool for information integration in the field of cultural heritage. Along with this, we have developed a set of control vocabularies. This has been a collaborative process, but to keep the data clean and searchable, we have to come up with terms for certain attributes because otherwise the variation can be too much. So, for example, over here, through a number of meetings with the collaborators, we have come up with a list of control terms for most of the attributes that we are using in the database. For example, archaeological certainty is only allowed the values of definite, high, low, medium, negligible, or not applicable. And they also come up with a set of definitions so that it's easier for the data digitizing team to understand and use them. Now that we have done all this work around the control vocabularies and what type of standardization we need to do, this needs to be brought up together in a format that can be used to digitize the data. That is basically a data recording template. Over here is an example of the CSV file data recording template that we are using. It has got a number of components. For example, on the top, it says site name repeat group, which indicates that one site can have more than one set of names that can be categorized as primary, alternate, village, or survey reference ID. And then there is some metadata associated with the attribute, that this is a control field or it is a string field. As you can see over here, name is an open string field and the name type is a control concept field. Then there is the attribute name to tell the person what to add over here. Then we have also enabled drop downs for control vocabulary so that it's easier to select the relevant value. There are color coded columns to allow the team to understand which set of attributes are grouped together, like site name contains name and name type, and similarly, heritage summary comes up with its own set of attributes. And each of these attributes is assigned a unique MAHSA ID so that these can be identified and imported into the ArcSys database. And now this is one type of data recording template that we are using because of certain limitations of low internet bandwidths. We need to keep some open formats, and that can work offline. But we have also made a QGIS template that is very similar to the previous template that we have just seen. This is allowing us to deal with data duplication in a very a centralized way because we are not, as I talked earlier, that we are also using some of the already digitized data set from the previous project. So there is a lot of chances for duplications. So this template, again, you will see that has a lot of resemblance to the previous one. Over here, you will see the MAHSA IDs. Then there is the name of the attribute and whether you can have more than one set of attributes for one site, like one site can have many assessment activities. Then there is the list for the control vocabularies, and there is a hint that you can select multiple from here. There are different cards on top to fill in the site attributes. And yeah, this is what we are using in the QGIS environment to digitize the data. Similarly, we are also using a standardized field data collection using the Open Data Kit. Again, to reuse the work that we have already done, it comes with the same set of control vocabularies where feasible. And then we are preloading some existing data set with some of the attributes into the field survey application that are so that the attributes can provide the surveyor with some insight, like what was the previous values recorded by the legacy data, and they can compare it with the condition on the ground and collect new data. Now here is an example of how you can break down a legacy data record into this structured template. For example, this is a example of Shahidabad Derai site from one of the legacy data sources. In the beginning, it tells you the map sheet number. Then there is a record of location, measurement, like it's 1 acre and some other information. So to break it down, you need to move the surveyor, the name Shahidabad Derai in the name cell, and the name type is assigned as primary name. Similarly, 901 is basically the reference ID that comes in the another row because one site can have more than one name, so you have the provision to add multiple names over here. For the location, there is another column where you document the WKT format location, say that whether it is recording the details up to degree minutes seconds or only degree minutes, and the type of the geometry. And the area gets broken down into the measurement type is area, measurement unit is acres, and measurement value is 1, with the reference to the legacy data source that you are recording it from. When this data is broken down into such structuring, it increases the data discoverability and findability. For example, you can apply filters on this data. So over here, you can see a screenshot of this data in ArcSys where I am applying a query that the measurement value needs to be greater than 5, the type needs to be equal to area, and the unit needs to be equal to acres. And the database has given me 90 results. If you open the first result, Gumbat Shah Baba site, you can see the area is 10 acres and the type is area, which meets our filtering and search criteria. Similarly, for the second site, the area is 9.27. So yeah, you can very easily do a query and search on the database. Also, if the data is properly structured, you can reuse it for different types of visualization and analysis. For example, here you can, this is a output of the data from ODK survey. And we have very clean values for the survey surface artifact densities which are being plotted onto the map in the QGIS, and you can see to get a quick idea of how the artifacts are distributed on this big site. We have, for some reason, less density of artifacts into the middle and more density as you move towards the transects or the diagonals of the site. It is very important to continuously keep on describing the data and have the documents that can help the team and the users to understand how to digitize and describe the data. So we are maintaining a number of metadata documents that include the name type, the data type, an explanation and example of what attribute can go into the particular field. And the data is also standardized on another level following the SciDoc CRM. All of the attributes have been assigned particular classes from SciDoc. Like this is a screenshot from ArcSys database where the name type is given a particular class from SciDoc, which is a E55 type, which has a particular definition, and anyone across the different projects or the users can go to the SciDoc CRM and see what is the definition of this class and understand the type of the attribute from there. We also need to think about what kind of data access levels we have to configure for this data. So ArcSys allow you to configure permissions at a few different levels. You can create different user groups, including the guest or someone who can edit the resources in the database or review, or the administrators who are managing or administrating the database. And then you can apply access restrictions for different user groups. For example, one of the use cases that we are dealing with right now is that we wanted to restrict the access to heritage location resources. So you can see if you open the guest or public access, you cannot, the heritage location resource model is not listed among the resources available. But a manager level access gives that in the listing over here. So you can control the access to data using these functionalities in ArcSys database. We are also doing the data backup using, for day-to-day working, there is a two-stage recycle bin that comes with SharePoint, allowing us up to 3 months of data recovery. And then we are taking the backup of SharePoint onto research cold storage because we need to keep a backup for our historical maps and the georeference copies. At the database level, there are scheduled cron jobs for automated backup, and these backups, these cron jobs create a local copy onto the database server and copy it over to the RCS as well. Here you can see the complete image of the data lifecycle, which I've just talked about. So it starts with different data sources. It goes into a number of formats like the relational geo package, structured CSV files, data inflowing from the open data kit that gets formatted and quality assured. It goes into a centralized Postgres database, which is helping us with a lot of data duplication and keeping the data centrally managed. And from there, it goes into the ArcSys database that serves as the final repository of data with different levels of access. It is important to note that even though ArcSys is an open access, but it's not an uncontrolled access like I've talked before. There are definitely different levels of access that ensures data security to keep it safe against the different concerns like looting of sites and conservation and preservation strategies. We are also focused on the long-term preservation, like we are evaluating and thinking about having a copy or a dump of the database onto the Apollo repository. But yeah, this is a continuous thing of discussion that we are looking into as the projects. I would like to conclude this with the acknowledgements to all the funding that we are receiving from Arcadia and all the projects that have helped us to reach so far. So thank you very much. And if you have any questions, then we can discuss. I'll stop sharing the screen now.
Brilliant. Thank you, Junaid, for giving us that overview. And as several people have asked, we will be putting presentations up on YouTube later. So if you've missed any details, you will be able to watch the presentations again, or do please ask us in the chat if you have any questions. I haven't seen any specific questions coming up in the chat for the presentations. Oh, we've got one question from Marco, if you have a very quick one, and then we'll move on to our final speaker. Thanks, Marco.
Yes, very quick. Thank you very much for both presentations. In terms of data reuse from an analytical point of view, are the two projects developing or plan to develop statistical approaches to overcome, issues that biases and various issues that have been discussed in terms of variability, heterogeneity of the data? I'm thinking like bootstrapping or that kind of approach, or simulations that can overcome at large scale and allows to use the data for maybe large scale pattern analysis. Are you planning on doing something on that, or are you currently doing? Thank you.
Thanks, Marco.
Junaid, do you want to go first?
I think yeah, it is an important thing to do process, but I think it will be something that we do when we have with a grown data set. So we are still like recording and documenting the data, but we have discussed this within our discussion groups, and probably this might come into the other discussion groups app that's there. So yeah, we will come up with something eventually, but not particularly at the moment.
Yeah, thank you, Marco. I think it is likewise. I don't think we have enough data in. What is important though is that we do flag the bias that we have, at least in the data set that we have collected so far, because we are basing it on the written records of our partners, so mainly sites and monuments records that exist. So obviously there is possibility for asking a lot of research questions of these data, but there are many research questions that cannot be asked. So the structuring, I think, may still impede some of the further analytical operations that are possible in the future. Whether we try and normalize the data or not, there are some things that won't be possible. But yeah, once we have enough data and see how many of our fields are actually empty or full, we'll be able to see what we can do with this data, because the database structure is quite big, but that doesn't necessarily guarantee that we will have all of the fields that are present basically for all of the data set that we are compiling. And a lot of what we then do with this will depend on the minimum number of attributes that we can even deal with. I don't know if I've answered.
Yeah, thank you very much. And I think it's something that we can pick up later on, across projects as well.
Thank you. Thanks for the question, Marco.